Good afternoon, class. Today what we're going to be looking at is the areas of regular polygons. This section is a little bit tough because we have to look back at section or chapter 7 of the book. This is the right triangle one where we're going to be using it a lot. We have to find different parts of a regular polygon. And to start with, we have to look at the different parts themselves. There's a whole bunch of different names. For regular polygons, we can construct these three shapes: sides, apophthegms, and radii. Wait, isn't a radius something for a circle? Well, yeah, there is something for a regular polygon used to find its area. In order to be able to construct the three, we need to think of the circumscribed circle. So if I look at a regular polygon, real quick, if I would have something like this here, a regular polygon, real quick, if I would look at something like this here, real quick, if I look at something like this here, this regular triangle, to look at something like its radius or its center or its apothem, it would make sense to draw the inscribed circle for this shape. Now, the center of this circumscribed circle is the center of my polygon. The radius of the circle is the radius of my regular polygon. The side of my polygon is still the side of my polygon. The apothem is going to be the segment from the center that's perpendicular to the bottom. So this is the apothem, this is the radius, this is the side length. And right away what I can see is these three have a relationship in the form of a right triangle. So I'm going to have to use sine, cosine, tangent, a squared plus b squared equals c squared to find unknown lengths. And last but not least, here's what we call the central angle. The central angle being formed by two radii of my shape. So for instance, this is the central angle here. And the central angle, to find the central angle, all you do is you take the measure of a circle, 360 degrees, and you divide by the number of sides, usually represented as n. So 3 sides in a triangle, so 360 divided by 3. So the central angle measure is 120 degrees. Here's me just labeling the things for you. The apothem is from the center to the edge of the circle, perpendicular to the side. The radius is from the center to the circle, or the vertex of my polygon. And the side is, of course, the side. Now, I told you this is how you find the central angle of a polygon. So, I want you to find the central angle for each regular polygon. I see a square, I see a pentagon, and I see a hexagon. So, if I want you to find the central angle, you don't even have to redraw the shapes. But what you have to do is you have to know the number of sides. So in the upper right, I know the number of sides is 4. In the upper left, I know the number of sides is 4. In the upper right, I know the number of sides is 6. And in the bottom left, I know the number of sides is 5. To find the measure of the central angle, all I do is I take 360 divided by n. So, for the central angle in the upper left, 360 divided by 4 is 90 degrees. Try the other two. Find the measure of the central angle. The bottom one should got 360 divided by 5, or 72 degrees. And for 6, you should have got 360 divided by 6, or 60 degrees. So again, each of those central angles are that measure. Now, so for instance, this angle right here is 90 degrees. This angle right here, 72 degrees. And this angle right here, 60 degrees. Why is that important? It's because when I look at this here, the radius, the apothem, and the side length, if I look at the right triangle here, the apothem is this length, the radius is this length, and 1/2 of the side length of my shape is this. If I know the central angle of this shape is 60, and this is a right angle, or sorry, this is the apothem, it bisects the angle. Wait. The six-sided shape was 60 degrees. So if it cuts or bisects the angle exactly in two, well, that means this angle right where my mouse is has to be 30 degrees. So I right away can find the measure of one of the angles of the triangle by using this method and cutting it in half. That's going to be helpful whenever I'm trying to solve for stuff. So let's just practice. I want you to find the unknown radius, apothem, and or side lengths. So really we're going to be looking at that triangle over and over and over again. But first let me redraw my shapes. Alright, so for this problem here, what I'm going to do to make my life a little bit easier is I'm going to redraw a triangle, a right triangle that might be helpful. And it's going to be one that's dotted right here. So I'm going to redraw it in the same orientation, maybe even a little bit bigger. This is the right triangle. This is 7. This is the apothem. And this is half the side length. It might be better to just call this x and realize that x is half the side length. So if I multiply x by 2, I get the side length. Now the central angle is 360 divided by 5. If I take 360 divided by 5, I know it's 72. Or if I cut it in half, 36 and 36. So that means this angle right here is 36 degrees. Now, we're just practicing to be able to find the apothem and the side length, or the radius, depending on what I'm given. And I look. Hey, I'm trying to find a and x, essentially. It's a right triangle. I know this is 36, so how would I find a? Well, I have one side length, I'm looking for another. Does that mean a squared plus b squared equals c squared, or does that mean SOHCAHTOA? Well, it means SOHCAHTOA because one side looking for another is always SOHCAHTOA. Me, I have a preference for x. So if I'm going to do x first, of course, if I know SOHCAHTOA, I mark the angle. This side is opposite, this side's adjacent, and this side is the hypotenuse. So if I'm going to find x first, I'm going to use sine because I'm looking for opposite and I have the hypotenuse. So sine of the angle equals a fraction. The angle is 36 degrees. X is my opposite side, so it goes on top because O is first. 7 comes second, so it goes on bottom. Or sorry, it comes third, so it goes on bottom. At this point, I could type into my calculator what the sine of 36 is. So might as well. The sine of 36 is 0.5878 equals x over 7. Alright, so if I'm trying to solve for x, cross multiply. X equals 7 times that number times 7. So I get 4.114. There's no unit, so x is 4.14. However, I'm looking for the side length. So when I'm looking for the side length, all I do is double that, 8.228. Alright, now that I know that x is 4.114, I have two of the sides, and I'm looking for the third. Pythagorean's theorem. A squared plus b squared equals c squared. So in this case, a squared plus 4.114 squared equals 7 squared. A squared plus something equals 49. So let's see. 4.114 squared, 16.92. Subtract 16.92 from both sides. So 49 minus second answer. I get 32.08. Square root that. And I get A to be roughly 5.66. You're not necessarily going to find nice numbers here, but this is how you're going to have to do it. Draw the right triangle and find the side lengths. This is really a review from chapter 7. Attempt that problem real quick. Alright, if you redrew the triangle correctly, this is what you should have got. Now, no matter what you do here, you're almost going to have to use sine, cosine, and tangent, like we did over here. However, if you remember the 30, 60, 90 triangle, if that's 30 and it's across from the shortest angle, that means R is going to be double it. So 2 times 4. So the radius is 8. It's the same as the edge of the circle. Or sorry, edge of the side in here. Wow, neat. A here. Well, A would be 4 times the square root of 3. Which I don't know off the top of my head, but 6.93. Alright, if you want more review on how to solve for a right triangle, it's back in Chapter 7, Section 7. I go over how to solve it in detail. But I'm not going to do an overabundance of examples here because you have that option. But the whole reason for being able to find A, S, and R here is because our formulas demand it. I need A to solve. If I don't have A, I have to be able to find it. If I don't know S, I have to be able to find it. And that's the whole point I was having you practice solving for those here. Is because when I look at the formulas, it's either going to be A equals 1/2 A times P, apothem times perimeter. Or A is going to be equal to 1/2 apothem times the number of sides times the side length. Which, by the way, is the perimeter. Remember, it's like regular, so each side length is the same. So, in this case, it's just going to be trying to solve for the part of the right triangle until I find A and S. And I plug into my equation. The perimeter is just going to be the number of sides times the side length, but the area is going to be, I need A, I need S. If I don't have them, I can't do this. So I have to be able to solve that right triangle. So in this case, I give you two shapes, and I say, find the perimeter and area of each regular polygon. Alright, so I filled in a few pieces of information. So again, I'm going to draw my right triangle here, because I know I'm going to need it. This is a right angle, this is 5. 360 divided by 6, the number of sides, well that's 60 degrees, and I need half of that, so this is 30 degrees. Now the thing that's very important to me is the side length and the apothem. If I know that, I can solve for it. So to find the area here, I need the apothem because the area equation is 1/2 A n S. I have S, the side length is 10. N is the number of sides, 1, 2, 3, 4, 5, 6. If I have A, I have the last number I need. So at this point, it's time to solve for A. 5 ends up being the opposite side. A is adjacent, and this here is the hypotenuse. How did I know to right away think about sine, cosine, tangent? I'm only given one side and I'm looking for another. So, TOA is the better choice because opposite and adjacent are the ones that I have. So tangent of my angle, 30 degrees, equals opposite 5 over adjacent A. You can punch this into the calculator right away if you wish, so that way you're looking at a number. So let's just do that. Tangent of 30 degrees is 0.5774 equals 5 over A. Cross multiply, 0.5774A equals 5. Divide both sides by 0.5774 and I get 8.66. Although I really shouldn't box that because that's not my answer. It's important, but it's not my answer, so boxing it might not be the best idea. So I'm looking for area, time to plug stuff in. Area equals 1/2 of A, 8.66, times the number of sides, 6, times the side length, 10. So area equals something real close to 259.8 units squared. Now, perimeter, All you have to do to find it is number of sides times the side length. Because each side length is 10, if I know that I have 6 sides that are all 10, 6 times 10 should be the perimeter. So 60 units is my perimeter. There we go. That's part 1 of example 3. I would like you to take a look at the next one, the other part, the one on the right, and see if you can find me the area and perimeter of that shape. Go ahead, try it. Alright, if you set it up, this is what you should have got right here. You're going to have to find both x and a, and it really doesn't matter which one you start with, but you're going to have to use sine, cosine, and tangent. Alright, I don't know exactly how you might have done this yourself. You might have chose to find using cosine first and you found a first, but you could have went about this slightly different than how I did. I found x to be 3.527 roughly. And doubling that, I got a number real close to 7.05. And that's the side length. I then used 3.75 for x and 6 for the hypotenuse, and a squared plus b squared equals c squared. I solved for a and I got that. So the apothem is this length, the side length is this length. And now that I've used my triangle to find the important stuff, now it's time to just plug in the formula. A equals 1/2 ANS. I plugged it in, plugged it into my calculator, that's the answer I got. The perimeter is number of sides times the side length, so 5 times 7.05. Plugged it in my calculator, that's what I got. So if you did it correctly, this is what you should have gotten. If you went about a different way and you found this first and then you found this, you might be a little bit off in decimal, but you should at least got like 85.5-ish. You should have got something real close to 35.2 or 3-ish. Alright, for example 4, there's a lot of these here. I'm not going to go over each and every detail, but if you wanted to try 1 or 2 of these, I just wanted to let you know what everything was in it and what the answers were, just so that way you could practice it on 1 or 2 of these and make sure you're doing it right. So, go ahead and attempt 3 through 5. Number 6 is not something I'd ask, but you should be able to answer that one too. Alright, if you did each of these right, this is what you should have gotten for each of them. The only one for number 6 that could be used using a special right triangle is this one right here, number 5. But anyway, there you go. This is the answers for each of them. If you got it right, good. If you didn't, see me. Or rewatch it and you might be able to figure it out, but see me. Alright, so this is a summary of when to use each of them. Basically, when to use trigonometry if you know only one side length and you're looking for another in your right triangle. When to use Pythagorean's theorem when you know 2 side lengths and you're looking for the third. Alright, that's all I have for you today. Till next time.